Welcome to Chemistry at Hananiga High School. Today we're going to look at our third and by far the shortest set of notes from Chapter 7. We're going to look at how you name ionic compounds. Now, a lot of the work about naming compounds really started with finding formulas and the discussion about the different types of ions. So naming ionic compounds is going to be significantly similar, or I should say simpler than what we looked at before. So naming ionic compounds, well, the first thing, remember, and you should have noticed this yesterday. We were always putting the positive one first, the negative one second. You always put cation, anion. That's true for formulas and names, but yesterday it was always written for you so you didn't have to worry about it. So remember, cation first, anion second. That's our first rule for naming ionic compound. And then second, you copy the name of the ions. And for the most part, all we're really doing here is looking at the back of the periodic table. So what is the cation called on the back of the table? What is the anion called on the back of the table? And that's really it. Now, since it's crisscross reduced, you do have to be careful because sometimes we have cations with multiple charges and we have to dig a little bit deeper. So we had to find out whether it was iron with a +2 or iron with a +3 or copper with a +1 or copper with a +2. But by and large, it's much simpler to name ionic compounds than it is to find the formulas. So monatomic cations use their element name. We already talked about that before. So if it's a cation, it's just what it's called. So the copper ion is still copper. Now, if it's a monatomic anion, we're going to take the root of the element name and we're going to add the suffix IDE. So oxygen becomes oxide, sulfur becomes sulfide, chlorine becomes chloride. So monatomic cations keep their name, anions end in IDE. Now, if an element can have more than one charge state, here's where we got to be careful. Remember, we use Roman numerals in parentheses after the element name. So, example, if it was iron 2, that would indicate that we had the Fe2 plus iron. So if we knew that it was iron with a +2 charge, we would call it iron 2 rather than iron 3. And remember, you're just looking these up on the table, so if you notice you got iron, you have to catch, oh wait, is this iron 2 or iron 3? And then look more closely. Now, what you're going to use is the charge and the number of anions to help us figure out what the cation is. So that's something that we're going to practice here in a second. So that's the trickiest of all of this, is doing that. So what's the name for MgO? Well, first I have to figure out what their formulas are. So if you look in the back of the periodic table, you find out Mg is Mg2 plus and O is 2 minus. Now, when we crisscross reduce, we go from 2 to 2 to 1 to 1. That's how we got the formula. But that's not what we're doing here. Here, all we're doing is naming it. Remember, cations keep their name, so I know Mg2 plus is just going to be magnesium. And this isn't a multiple charge one, so I don't need to call it magnesium 2. But remember, if you're not sure, look on the back of the periodic table. You'll see Mg2 plus, it's called plain old magnesium. And then look at the back of the periodic table, find O2 minus, you'll see that's called oxide. So literally, it's magnesium oxide. If you can plagiarize, you can name these things because that's what you're typically doing is just copying off the back of the periodic table. Now, what's one that's a little bit trickier? Well, we've got two things really going on here in this one. We now have a polyatomic ion, but remember our ion test is helping us to recognize and see that, oh, that's SO4. What was that thing called? Oh, maybe that was called sulfate. Well, honestly, recognizing that it exists, looking on the back of the periodic table, you're going to find out what it's called. So that process where you're starting to think about polyatomics will really help you with this. So we go and look on the back, and I notice it says copper is a +1 or a +2, and it says SO4 is SO4 2 minus, so I'm going to write that as SO4 2 minus. And remember, we always put polyatomics in parentheses. Not that I really need to here, but I just want to be consistent. Well, and that's called sulfate. So I know the name of my anion, but I don't know if it's copper with a +1 or copper with a +2. So I'm not sure if it's copper 1 or copper 2. Well, here's where we have to play detective. And remember, the anion is going to help us find the cation charge. So you always use what's going on with the anion. So you're going to use your anion and the number of those anions to help figure out what our charge is on our cation. And we can't just uncrisscross because we may have reduced. So don't fall into that trip. You really need to do the work. And it's not hard work. Here's what you have to go through and do. Now, first, it could be +1 or it could be +2. So how do I figure it out? Well, I know it's CuSO4. 1 Cu, 1 SO4. And I know SO4 is a 2 minus charge. So I know my total negative in CuSO4 is -2. Now I knew the total had to add up to 0. So what does my cation have to equal? Well, it had to be a +2. I've only got one copper. It just says Cu, so that means 1. And that must mean that one copper has to have the full +2 charge. So that's how you use the anion to figure out the cation. So in this particular case, I knew it's Cu with the 2 plus, which means it's got to be copper 2 sulfate. So what would happen if it was Cu2SO4? Well, the reasoning is still pretty much the same. So let's go back a second here and take a look at what we've got. I know that the total has to add up to 0, and I know my total anion charge, I've got 1 sulfate, that's 1, -2. And I know my total cations have to be a +2. But the difference here is I have 2 of them. So that means each cation had to be a +1. Since I had to have a total of +2, and there were 2 of them, that means each copper was a +1. So I had copper with a +1 in that case, and that would give me copper 1 sulfate. So that's how you use your anion to figure out your cation.